Hey there, thanks for listening in and welcome to another Ellipsis Drive Podcast. Here we dive into the stories of people, companies, and technologies that transform and empower spatial data-driven industries. My name is Rosalie van der Maas, and today we have Jed Sundwall with us, calling in from Seattle, Washington. Jed is Executive Director of Radiant Earth, and Radiant Earth is focused on, and here I'm going to quote, increasing shared understanding of our world through community-led initiatives that make data easier to access and use. Now, it's nothing new at Ellipsis Drive. We believe in the power of data and the importance in making it usable for every stakeholder in a frictionless way. So I'm pretty excited to hear Jed's views about this. Then without further ado, Jed, welcome to the show. It's great to have you. Can I ask you to start us off with a nice introduction about yourself and your journey with Radiant so far?
Yeah, sure. It's great to be here. Thanks for having me on. My background has been in data policy, science policy for a long time, but very much on the practitioner end, not so much like making policy, but like responding to things like open data policies and other initiatives to make data easier to access that usually come from governments, and then figuring out how to implement that. The bulk of my career, I would say, was spent at AWS. I think that's where it's the longest job I ever had was working at AWS, where I built the open data program. And it was there that I, as with many people in geospatial, kind of accidentally got into geospatial data. We were building a thing called the Open Data Program just to host any kind of data. And I think our first big hit was when we started hosting Landsat data on the cloud. And in the process, I say inadvertently created what's now called the Cloud Optimized GeoTIFF. But that's kind of how I fell into this community and fell in love with it and working with geospatial data. And so about 2 years ago, left Amazon to take over Radiant Earth and do what we're doing now, which I guess we'll talk about. But I'll I'll let you lead the discussion from here.
Yeah, sounds good. Will do. So you were really there when like the cloud optimized GeoTIFF was born, or just the GeoTIFF in general?
No, so the GeoTIFF had been around for a long time, and even like the idea of using internal tiling on a GeoTIFF, which is sort of one of the hallmarks of a cloud optimized GeoTIFF. That was an established practice that people would do. GDAL would, for your listeners who know what GDAL is, it's a tool that would allow you to create and manipulate raster data or all sorts of geospatial data. It had affordances to create things that you would call the cloud optimized GeoTIFF. What ended up happening was, we decided that at AWS we were going to host a lot of Landsat data, and I was insistent that I didn't want to host tarballs. I didn't want to host big gigabyte tar archives that contained a lot of imagery, because I knew that most people didn't use most of that data. And so through talking with a lot of people in the community, we landed on this approach, which is, let's put the TIFFs in the cloud and let's arrange them so that people can stream them very easily using internal tiling. And that was the approach we took. We didn't really call it anything special. It was just like, there's some TIFFs in AWS and you can access them in this way. And it was Chris Holmes that a lot of people in our community know. He gave it the name, the Cloud Optimized GeoTIFF, and that's how it became a thing. I'd say it was sort of an accident. It was all we were doing was trying to make the data easier to access, and it ended up becoming a pattern that people really liked. And so that's how it became a thing.
I certainly also would be inclined to attach the name Chris Holmes to Cloud Optimized GeoTIFF, but it's interesting to sort of hear like another player in that game as well, because it's not just from Planet Silo sort of. It's usually a team effort. Sorry for the sidetrack there, but it's interesting. Yeah. So indeed, let's dive into what is close to Radiant Earth's heart, and that is basically removing hurdles around the use of data by stakeholders within various different situations. Of course, this podcast is primarily focused on geospatial data. So in your view, what are the biggest hurdles that are preventing interdisciplinary collaboration on geospatial data throughout ecosystems?
Boy, I mean, there are a lot. I think one big one, which is the thrust of a lot of our work, is the fact that data is just getting very big, right? So compute power keeps getting more powerful, computers keep getting smaller. The result of this, we also have lots more network connectivity around the world. And so the result of this is many more sensors everywhere. I forgot one thing. Also, it's getting cheaper to launch stuff into space. So like there are just all these factors that point towards just more and more data being produced. But sort of the physics of storage dictate that like a lot of people want to work with data or could work with data that is too big to fit on a single device. It's not you're never going to download it locally or fit it on your phone. So you have to work with data that's stored remotely somewhere, and increasingly that's in a cloud environment. And so one of our big initiatives at Radiant Earth, we have a number of initiatives, but one of our biggest one is a thing that we call the Cloud Native Geospatial Forum, where we convene people. It's a vendor neutral forum, so it's not explicitly tied to any software provider or any particular cloud, just to get people to talk about like what works and what doesn't work, right? So like the cloud optimized geotiff is something that some people like and they use a lot. Increasingly for vector data, people are interested in GeoParquet. And so these are attempts, led by the community openly to create patterns and best practices. They might become standards over time to work with data that's, again, largely going to be hosted in a remote environment. That's totally new, though, for a lot of people. This idea that, a lot of people, I think they're used to downloading data, having it locally on a file system and opening it up in apps, on their computer. Increasingly, that's not how things are going to be done, but that requires a lot of training, and it's like a cultural shift that's underway. So that's a big hurdle. Geospatial data also is sort of frequently treated as like a different kind of data. Like it's treated very distinctly, that you only interact with using a distinct interface that's usually map based. I think that's a problem. I think a lot of decisions get made in other systems like business intelligence systems and other kind of like reporting paradigms that might not fit a map, but you still want geospatial data to get into those environments. And I think that's another hurdle we have to overcome, is to figure out how to get Javier de la Torre talks about this a lot, breaking the GIS silo. Like all the GIS stuff is done in its own silo. We need to get it out of that silo.
Yeah, that's funny. One of our company leaders actually changed their LinkedIn tag like permanently to breaking down geospatial data silos.
Oh,
So
great.
that's Ren's actually, him.
Yeah.
But yeah, it's something of a crusade for him as well. And yeah, I understand. Like spatial data has always been the special snowflake, and it's very annoying to everyone who is not like a GIS specialist who sort of went to school because it's a special snowflake.
Right.
But there's always the rest of us. So yeah, that makes sense. So you've touched on hurdles. Let's touch on solutions. So around the geospatial data infrastructures that are out there, or data management
Mhm.
solutions that are out there, like you mentioned, the cloud, of course. But what type of
Yeah.
solutions do you find there? Like, how would you group them, in your opinion?
Well, I mean, my vision is one of a world with like many, many solutions that are pretty, bespoke and esoteric in some ways. I tend to focus a lot on like environmental data and less sort of like climate and sustainability solutions to things. For what it's worth, I'm actually not in Seattle right now. I'm in New Haven. I've been teaching Yale this fall on,
Oh, that's my bad.
no, it's fine. It's totally like I'm more normal. I'm home is Seattle. I'll be going back to Seattle after the semester, but I'm out here to teach, about improving access to environmental data. That's sort of the reason they brought me out. And the one of the challenges that I think our community faces, the geospatial community, but I would also say it's a very broad challenge societally, is that we tend to want to build software solutions, or we have this vision of software solutions that like someone's going to create some SaaS application that solves everything, that makes geospatial data accessible, and then everyone will use it to make the right decisions for the environment or something like that. And I'm like, sure, like we do need services that can help people interact with and manipulate geospatial data, so to design interventions or actions, where they are related to climate change. But frequently, what needs to happen locally is very esoteric. Like it's very specific to that region, and like their access to water, or the kind of food that they eat there, or whatever cultural issues. So software is not going to solve that. I think the solution we like our sort of overarching like approach at Radiant is just like, can we continually lower the cost of working with geospatial data, so that somebody in the Netherlands can come up with like a specific service that's like very relevant to their community in the Netherlands, and somebody in Vietnam can do the same sort of thing. So I know this kind of sounds like a non-answer, but I do expect lots and lots of solutions to be built. but on top of open standards, sort of generic approaches to accessing and interfacing with data. The only other thing that I'll say very specific, I think one thing that we do believe pretty strongly about is that cloud-based object storage, so things like Amazon S3 or Azure Blob Storage or Google Cloud Storage, that's a commoditized and very powerful tool that's increasingly affordable and performant and is very flexible. Like if you put something in an object store, you'll always be able to get it out over HTTPS very efficiently. And I think that's like when people are like, what kind of API do you like? I'm like, HTTPS. That's my API of choice. So anyway, I think that's kind of the solution, is getting people to align around like very generic standards and approaches to sharing data.
That makes sense. Yeah, I think, and I'm curious about your view on this. When we talk about, data standards, and there's of course the Open Geospatial Consortium that
Yeah.
that operates a lot around this. We sometimes also find that standards can actually be too abstract, that
Oh
in
yeah.
specific situations they're so abstract that they're actually hardly a standard, so that they're indeed still defined as such, but they're not as useful as we want them to be. Have you sort of ran into those, or do you recognize the standard that's too abstract?
Oh yeah, yeah. I mean, first of all, I always want to say like we're good friends with OGC. We actually
Sorry,
just
we're part of them, so we're always part of
yeah.
that discussion.
Yeah. Well, the thing I feel like I always feel like I have to say this because people think that like maybe we're competing with them. We are explicitly not a standards organization because it's really hard to create good standards. What OGC does is very important. And in fact, we just announced we're going to do an event in Utah in the end of April 2025. And OGC is one of our collaborators on the event. I am of the opinion that a standard is only really counts if it's used, right? So if it's too abstract, if it's too complex, and it doesn't have uptake, it's kind of like a tree falling in the forest and no one hears it. That's like, is it really a standard? Like if no one actually uses it. What I think what the internet has enabled, as more and more people get on the internet and more people are building stuff on the internet, it's enabled what I call emergent standards. And I also think the cloud optimized GeoTIFF is an example of this, where you get a handful of people to do something that like they're reasonably smart. They can find a pattern that makes sense. And if it works and it gains traction, then it becomes this emergent sort of de facto standard. That's great. I think that's how like Markdown, very popular schema, for marking up text. There's no organization that created Markdown and foisted it on the world. RSS is a similar thing that happened somewhat emergently. So I'm very interested in sort of enabling the creation of those sorts of things, and also recognizing that when they become big enough and useful enough, it's really good to have an organization like OGC or some sort of steward to come in and mostly to pacify governments who really like standards and just be like, look, it's okay. You're allowed to use the cloud optimized GeoTIFF. Like because there's so many governments and organizations like, oh, we don't know if this is really a thing, and so we don't want to use it unless it's a standard. So
That's a very good point you make there.
yeah,
And then I also understand like sort of the emphasis that Radiant Earth has on the community-led part of it. Like if it's
right.
being used, then it must make sense. So then like more attention should go towards like, spread the word, like that type of ideation.
That's exactly right. And it's a tricky thing that we're doing, I'll say, in that like I would say a lot of nonprofits and I would include ourselves in this, we're somewhat meek. We're like, oh, we're just doing what the community wants. Like we want to just kind of like say like we're just here to support the community and let the community lead. I do think we should lean in a little bit more into leading though, and to say like, no, like this makes sense. The community wants this. Like I think we should advocate a little bit more for our approach. And so I'm really just kind of like talking myself into being like this more. The community led part of what we do is really important, but I think it's also very important that I would say like absolve myself of the need to like be a leader or like have Radiant Earth like be seen as a leader in the community.
That makes sense. It
Yeah.
does. Like communities and community-led development is key, but at some point it can also be like relatively steerless, or
Right.
you can sort of lack like a long-term vision on matters. So then it is good to have a few leading parties that can provide
Yeah.
direction to the degree that it's necessary. Something I wanted to ask about, because you guys are an NGO and there are lots of NGOs out there around like data usability and open data. And of course, NGOs that benefit from that are, for example, NGOs around conservation. And I'm mentioning this because you said that you personally are a big fan of a particular type of API. But what we've run into time and time again is that most sort of non-data specialized NGOs have a very limited capacity of people that can actually work with an API. So
Right.
what's your vision on sort of the interoperability and capabilities of collaborating with non-technical folks, but also with people who don't identify as a data engineer or a data scientist that are comfortable and excited around, what S3 is bringing us, because they frankly don't know
Right.
what you're talking about. Sort of how do
That's
you
right.
see
Yeah.
how do you see that gap being bridged?
So, I mean, I wanted to be bridged by the market, right? And so this is a sort of a drum I've been beating since I was at AWS. You know, when we started hosting a lot of Earth science data on AWS, people were like, "Oh, are you going to create the next Google Earth engine?" And I'm like, "No, that's not the business that we're going to be in. Um, I want to make it 100 times cheaper, 1,000 times cheaper for somebody else to build the next Google Earth engine." And there's in a somewhat direct, directly that happened with Sentinel Hub, from Synergize. They created a really powerful tool, and I think they were able to create that tool because there was massive volumes of data just sitting there for them to work with in S3. So they're very good working in the cloud. They were able to build an interface that a lot of mere mortals could use. They're kind of the most overt example of this, but I think there are a lot of there are plenty of people that started building interfaces on top of the data that way. And so my stance on this remains unchanged. I think if we can make things a lot cheaper and standardized for the developer community, they will be able to figure out how to take things the last mile, and in some cases build like what I would consider kind of blockbuster product like Sentinel Hub. In other cases, they might be building a very simple dashboard for a very small community, and that's great. So I think that's the answer is to make things cheaper to get to the market.
Got it. So what you're working on is something very, very foundational. You expect mostly companies to jump into the gap that still needs bridging. And I suppose we ourselves at Ellipsis Drive are part of that pool of companies
Yeah.
that is doing exactly that. So that makes sense. Great. So then another question I had for you has to do about sort of the technological advancements that we see in the industry that you would consider most impactful for like geodata management ecosystems. So like what is changing in technological field that is shaking up geospatial data management and use?
I mean, I do think I'm really excited about the columnar formats. I mean, like GeoParquet specifically, and then this work that's being done on things like Ice Chunk, which if I don't know if you've seen that, it's a bit out of my depth in terms of making much more complex what we call n-dimensional array data easier to access and work with. These approaches, I think, are going to break through the GIS silo. And start making more geospatial data more broadly, just like more environmental data, more easily integrated with the systems where decisions get made. I talk about this a lot. Like I was at Amazon for a long time. I very rarely saw people using maps to make decisions within the company. Typically, data ends up being distilled into some sort of tabular format, and then ultimately down like into a sentence, that an executive reads and decides to make a decision based on. I think we need to sort of transcend the map. Like, I love maps. I don't want people to stop making maps, but like the way to get data into the minds of a decision maker, it needs to get out of the map and frequently into a table somewhere. And so that's what I'm really excited about, seeing that happen more frequently.
So it's funny you mentioned this. Like you're basically saying like, what's out there in terms of data standards, like what we expect and also what we're able to like compute with is table-based data. And a lot of map data
Yeah.
is very difficult to stuff into a table, but one way or another, you're going to have to anyway, because that's how decision makers make decisions. But this is something I've noticed within the industry myself, especially because indeed the rise of environmental data and the importance of
Mhm.
it is growing throughout industries, like from conservation to civil engineering to like property and casualty insurance, because the spatial risk we're running due to climate change, climate risks, etc., are growing, and all of the data that's being produced about that is raster data. So have you noticed sort of this technology gap within the market where indeed like the major well-used compute engines and analytics engines are tabular engines, where in that sense the raster engine is sort of missing? Yeah, so what's your take on that, or where do you see a solution direction, or do you think it may not be necessary, that at the end of the day you're going to have to deal with that table format anyways?
Yeah, I think, I mean, this is very hand wavy, and this is just a hunch. I also know that I mentioned Javi before, Javier de la Torre from Cardo. They've been talking about somehow like fitting rasters into databases. They've been working on that. I do think some distillation of signal or information into a table is the way things are going to go. The pattern that I can see emerging, I'm a big fan of H3. I think H3 as I don't know, a gridding system, I think, or a binning system for data is really compelling and useful and interesting. It doesn't handle weird projections well, but like nothing handles weird projections well. And H3 is good enough to make sense out of data where most people on the planet live. And so I think it's, the pattern of binning data, or reducing information you could get from raster data and then distilling that into H3 cells and making that available in a table. That's a pattern I can see happening. But yeah, I mean, regardless, it's weird. I would say like making that jump from raster data to tabular data. And the other thing I'll say on this though is that like raster data, pixels and everything like that, the concept is entirely based on the concept of like rendering data in a way that a human can observe with their eyes. And when we design software, when we build, human interfaces to things, of course we think about human cognition, the way that we receive information. We receive a lot of information through our eyes, so we have a very strong bias towards like visual interfaces. Most data is not going to be consumed by humans. It's already not mostly it's mostly being consumed by algorithms, and if you want to call them like AI agents or something like that, you can. But like, I think we really need to be thinking, how do we make geospatial data like actually useful to machines and stop focusing so much on, making it visible for people
So
at first. Yeah.
yeah, and that's a good point you're making. Like, I agree with it. I have one asterisk there myself, for argument's sake, and that
Yes,
is
please.
that for like the sort of the table versus the raster engine type situation, in which a raster engine isn't like, there's no one dominant in the market for that at the moment.
Yeah.
The need for that is actually also existing when you feed that content into a machine, because when you
Right.
run like AI models or a complex query that needs to be spatially aware, you can't like chop up or distribute a raster image, for example, in such a way that respects spatial nearness. So when you want to
Right.
calculate, for example, aggregated risk, and you want to understand an event space of a flood, for example, you can't ignore the fact that you need to distribute that across nodes in a cluster in a spatially aware way. And that's
Right.
basically where we see this complete roadblock when you're doing things table based. It's niche, it's specific, but it
Yeah.
is one that we've noticed. But what you're saying about, at the end of
Yeah.
the day, it's more about consumability for computers than for the human eye, even though it can be very attractive. Yeah,
Yeah.
I see that, definitely.
Yeah. No, I take your point, and yeah, I'll admit to being maybe in a bit out of my depth, but like maybe would also H3 help with that though? I mean, the sort of the
Yeah, it's
distilling data into that. It's the same sort of thing, I would say.
it's not something I've considered yet too much
Yeah.
myself. So I'm gonna go ahead and try to tag some links onto this
Sure.
podcast to see if we can like refer onto some resources. But yeah, so let's go on to some closing thoughts here, considering the time. So for
Yes.
Radiant Earth, what are the goals for 2025?
So, like I said, we're doing an event in May with the Cloud Native Geo Forum, which is very exciting. That's our first in-person event, and so you're free to come over from Europe. Anyone can come to the mountains. So that's a big one. I guess I would say the goal is to sell that thing out. I think we will have room for like 300 or 360 people, and then we have a lot of plans for we have a data publishing utility called Source Cooperative, and we need to get out of beta. And I hope we can get out of beta in the first half of 2025. And what that's going to require is a touch more engineering and site reliability work that we're doing on it. We recently got a grant for that. But it's a data publishing utility that we've built to make object storage, like I mentioned before, more accessible to people. It's not explicitly focused on geospatial data, but those are our two main initiatives that we're mostly focused on. And then I've got some other plans that I'm not ready to announce yet, but I'll just say that we have some goals related to helping people working in geospatial to advance their careers. And I'll be explicit about this, and to get paid more. We want to help people grow in their careers. And so I think we have some ideas of how we can help with that.
All right, sounds really good. Some things to
Yeah.
look forward to, and some other things to still be revealed in like the first quarter of next year. Like, when are we thinking?
I would say first half. I can't.
First
It's hard
half.
for me to see a full year out. So
Fair enough. Fair enough. All right. So with that, it is time to wrap up. So on behalf of our listeners, thank you so much for sharing your insights and sharing your thoughts and having this discussion today. And if you're tuning in and you'd like to know more about any of the concepts that have been mentioned, we will leave some links in the description so you can find the resources you're looking for. So thanks for being here with us today, and until the next one. Cheers.
Thanks.